you, Dr. Kasra. And good morning, everyone. Somebody for good evening. Thank you for joining this session. My name is Makoto Taniguchi from the Research Institute for Humanity and Nature, Kyoto, Japan. And I will be chair of this session from now. Okay, so this session, the title is the Sustainable Groundwater Management toward the SDGs. So we particularly focus on the groundwater part of the water, but also that related to the Sustainable Development Goals. So today we have 4 speakers and also panelists, and we plan to have a 30 minutes general discussion after 4 presentation. So maybe, you know, that after listening the each talk, you can make any question during the talk in the chat box, and we can answer at the end the discussion, general discussion time. So I'm gonna start from my talk. May I share the PowerPoint presentation? Right, so I hope you can see my PowerPoint. So now session title is the Sustainable Groundwater Management toward the SDGs. And I'm gonna talk the global and also local groundwater issue related to the SDGs. So this is how we have a historical change related to the groundwater and industrialization in Asia. You can see that the y-axis real GDP share in the world, and since 17th centuries up to now, in a pre-industrialization period, the real GDP share is highest in Asia. But during the industrialization, that Europe and the US increased, and after 1950, I mean after World War II, Asian ratio increased again. So you can see the shift of the economic driver. And before pre-industrialization period, large population support in monsoon Asia can make this kind of the high share of the GDP in Asia. But in industrialization period, global economy rise by fossil fuel, and energy transition to the fossil fuel and the economic boom in Asia occurred after World War II. So combining the fossil fuel and the abundant water, including the groundwater in Asia, created a huge economic development and environmental problem, such as land subsidies and also groundwater contamination and so on. And if we look at another historical revolution, such as Green Revolution and the groundwater issue and related to the food. As you know, the Haber-Bosch method can make artificial chemical fertilizer, then we could increase the food production. Then we can reduce the poverty. On the other hand, we need a lot of water for food production. So you can see that the left figure, how much increase of the groundwater irrigation for food production during the Anthropocene. You can see the increase of the percentage of the area irrigated with groundwater to total increase rapidly after 1950, particularly in the US or India. So increase in the groundwater consumption for irrigation in Anthropocene was found. Then the middle figure shows how much virtual groundwater flow through global food trade during the among the continental scale. And you can see that a lot of virtual groundwater trade occur from Asia to Africa or other area, and also that from other continents to Asia. Then we found acceleration of the groundwater depression occurred, which was 12 billion ton per year 1960, but it increased up to 28 billion ton per year 2000. So the big groundwater depression occurred globally. The third issue is urbanization and the groundwater energy food nexus. As you know, that world population increase more than 7 billion now, but will be more than 9 billion up to 2050. And also that urbanization increase, it was 30% at 1950, but it will be 68% at 2050. So this is another third issue of the groundwater and other environmental issue. Then we conduct that groundwater food energy nexus project under the Belmont Forum framework, and intelligent urban metabolic system for green cities of tomorrow. This is the title of our project. And we invited not only Japan, but also Taiwan, US, and Brazil to compare that urban water energy food nexus. There are several scenarios we have developed, including that food policy. And when we increase the food sufficiency ratio, how much the water and energy change for that. And also we concerned about the climate change scenario, and we conduct the 8 GCM model, and we predict how much the nexus change. And we also think about the disconnection of the groundwater management and other resources management among the different sector and institution. There are many disconnection, such as conservation versus development, and consumption versus production, and also the disconnection of the resources management, such as water, energy, food. So if we have a newcomers, such as water spring power generation or the micro hydropower, we have to think about which ministry have to take care, water or energy or food. And also global versus national versus local municipal management, also another disconnection of the governance. So we adopt a nexus approach for system dynamic, and we care about the trade-off synergy between resources, including the groundwater, and a society, economy, environment, local, national, global, and past, present, future toward the SDGs. And we collect all type of the data related to the social, economy, environment, food, energy, water, and the climate change data too. And then we made the indices, how much the indices related to the SDGs. And we can see that the bottom left figure, that the indices of the sea water, sea means social and environmental economy. And the second one is sea energy, and the sea food, and sea land, and the sea SDGs, the right top figures. So warmer color shows less sustainability, and blue color shows more sustainability in terms of the sea nexus indices. And I want to share that one case study, that recovery of the lost synergy of the groundwater energy food nexus, which has happened in the Kumamoto city in the Kyushu Island in Japan. And Kumamoto city depends on the 100% of the groundwater as water resources, which is recharged at the upstream of the basin, which is out of the Kumamoto city. And recently, groundwater depression occurred in Kumamoto cities. And then we conducted the research, and we found that the increase in impermeable area in the upper stream of the basin, and also government policy change due to the decrease of the rice production. So it caused the decrease of the groundwater recharge rate in the upstream recharge area. So Kumamoto city decided to have a transboundary governance of the groundwater, and Kumamoto city pays subsidies to the farmer who recharge water into the paddy field, which located outside of the Kumamoto city. Then the groundwater in the Kumamoto city recovered, and also they could use the groundwater other water resources. So this case, the nexus synergy is rice production with the groundwater recharge in upstream, as well as the groundwater use in downstream without any additional energy for water allocation. So once Kumamoto City lost this nexus synergy, but now they recover with a transboundary groundwater governance. So this is a summary of my talk. And food and industrial material goods which consume the groundwater are globally traded. Then a distant area and a country are indirectly connected with the groundwater footprint. Therefore, groundwater issue is not only a local issue, but also a global issue. So for achieving the sustainable development goals, it's important to manage groundwater as nexus, which connect direct and indirect local and global water, energy, food, and economy, environment, and society. And thirdly, increasing efficiency of the groundwater use makes reduction of the energy consumption. Then it creates a synergy among the water and energy for carbon neutrality and a sustainable groundwater management. A good practice such as Kumamoto with synergy of the nexus and transboundary governance of groundwater is important for achieving SDGs, not only locally, but also globally. Okay, that is my talk. And I hope I could keep the time of the presentation. Thank you so much for your attention. And